Booked example 5 looks like this. So let me draw a line. And if you haven't done 5, you can go straight underneath this. What's being asked here? Okay, so they say you've got a continuous random variable whose probability density function is, and they hand you that, right? So in this case, they're actually just telling you this is the answer, right? You don't need to check whether it is. It's been checked for you, as it were. So I'm just going to write up, this is worked example 5. F of x, my probability density function, is given by 3x squared. Okay. They give you also this interval, so you're like, oh, wait a second, I have to remember how to define regions, not just with my inequality notation, like this, but also with interval notation. So it's written as, you got your square brackets, right? 0, 1. How would you translate that, by the way? You've got to be able to read both, but how would you write this with inequalities? From 0 is less than or equal to x, which is less than or equal to 1. Is that okay? So these are equivalent, okay? So they're telling us that it works on here. What does the question actually ask? It says, what is the probability of this particular x value being between half and 1? Inclusive. Inclusive, right? Yeah, okay. So how am I going to interpret this result right here? Kind of a straight substitution, isn't it? We've given you an f of x. They've even supplied to you what the a and the b are. What's the a?
0.
Look carefully. It's a half. That's what we're particularly interested in here. And then when they end all the way at 1. So I'm just going to go straight from that definition, and I'm going to say the probability of a half is less than or equal to x is less than or equal to 1 equals, and then I write my integral, okay, from a half to 1 of 3x squared, that's what they gave us, with respect to x. Happy? And then you're like, okay, I'm in calculus mode now, right? So you can tell me the primitive of 3x squared, it's going to be x cubed, fantastic. Evaluate that from half to 1. Let's see here, so 1 cubed, take away a half cubed, 1 take away 1 over 8. So this is 7/8. Happy with that? Which, by the way, should make sense. You don't need to do this, but if you have an image in your mind of what this probability function looks like, it is helpful. Picked up the wrong color. What does 3x squared look like in the domain that we've been asked for? Well, it looks very similar to what we were doing just now. It was part of a parabola. It's defined, you remember, from 0 to, let's call that 1. Okay? And you're like, I'm interested in the part from half, which is here, all the way to 1. And you can see, even just by looking at my, hurried graph, this is the area we were calculating. Of course, most of the probability, 7/8 of the probability is over there, because this is much more likely. Okay? One last thing we just need to be really careful for, and I wanted to pick out this example to notice it. This is my x-axis here, right? X, and this is f of x. What is this value up here? What's it equal to? Have a think. This function is 3x squared, remember? Have a think. Think carefully.
No, that's it.
If this is, you integrated, right? This is f of x, which is 3x squared. So the x value that goes with the spot I picked was 1. So you put in 1, you get 3 times 1 squared. So this is 3. Right? Now, I just want to highlight, it's a little bit weird because we've been thinking about those histograms, those frequency histograms, and when you do it relative, like the highest you can go is 1, right? Because all your probabilities add up to that. But these individual values here, like 3, that's not a probability. The area is the probability, okay? So you might get weirded out by the fact that your graphs for probability density functions will look a bit different to your histograms that we've been doing in discrete random variables, okay?